in this, especially in this context of working, that we want to induce ourselves in a very productive mode. And Jack has been exploring this phenomenon, connecting a lot of different complex concepts, and also engaging the design and the prototyping. So this is a very exciting project, and this is also the last step of Jack's Master of Science process. So I hope this is a very nice ending, and very looking forward to Jack's presentation. So the thing will go like this. Jack will give you a half-an-hour presentation, and then we'll be open for Q&A from the audience. Let's go that for maybe about 20 minutes. And then I will go back to my office with Heis online, and we will decide on the final grade. That will go about 15 minutes. Then Jack will join us for a final evaluation session. Then we will come back to this room with you, and you will observe Jack's signing moment for his certificate. And then the celebration follows. So this is about a process, and I hope you all enjoy this. All right, I give you the floor, Jack.
Thank you. Yeah, thank you for the introduction. That was a very complete introduction about the project, so I can skip my own, which is great. But the title slide, today's project is called Constructing Fidgeting, and I mean that in two ways, both constructing a physical object fidgeting and also like the space of knowledge around fidgeting. So I'm going to restart my timer so I know how long I'm going for. Yeah, as Han said, we have a schedule. I'll present and then feel free to ask questions. I'll ask you to keep the questions to the end and write them down if you were about to forget, because there's going to be a lot of info. And first, I need to give a thank you to everyone here and online. Even though I only have 30 minutes, this feels valuable to share. I see people from my Frisbee team, from my classes, from support groups, from my college back home, all sorts of things, my parents. And to have such a diverse group is just like very heartwarming for me. So I appreciate you all being here. And also, we mentioned Heis, he can't be here today, but that's him. He's online. So if you see him on the Zoom, he's also part of this project. And yeah, so as to the project itself, this is what I will talk about today. I'm going to give you a bit of context about fidgeting, what it is, why we do it, some theoretical research I did, a theory I made, some more research, and then how that all translates into a physical, actionable concept. And again, all questions, keep them to the end, but think of them. So just a bit of a briefer, this is a design program, and design can mean many different things for many different people. We do user-centered design around here, and specifically in this project, I researched a lot of things in psychology, cognitive science, and anthropology, which is maybe not what you would expect when you think of engineering and design, but a lot of what you're about to learn comes from those fields, so it's worth just mentioning the origin of these things. Okay, so fidgeting, you may recognize this thing. This is a fidget spinner, and it was super popular in like 2016, 2017. It was like in vogue, everyone had one, kids in classrooms all around the world had one. And some people said it made you pay more attention or focus people, but then kids started swallowing pieces, and just there's a bunch of debate whether it's good or bad or these sorts of things. But I would argue this isn't really fidgeting. It's one thing, you can fidget with it, but this is much more representative of fidgeting. It's a collection of objects, some purpose-built, some not, a paper clip, earbuds, these sorts of things. These are what we fidget with on a daily basis. And fidgeting is, in my definition, some sort of physical interaction we do that's unrelated to what we're focusing on. It's secondary. It's repetitious, really small, often handheld, and it often has no explicit purpose. Like we don't really know why we're doing it. So when I reference fidgeting, this is what I'm referencing. And as Hyon graciously introduced, I want to do something with fidgeting. And the goal is what we're calling affect self-regulation. I'll define that on the next slide, but helping people move toward a productive mood. And this is going to be done through what are called implicit interactions. And these terms I will define, so hold on just a second, but that's the goal. Help people to achieve this productive mood state through implicit interaction. So affect, as I mentioned, for our project and in psychology, that's defined as the experience or feeling of mood and emotion. So it's just a catch-all term for mood and emotion. And you can define it many different ways, but we choose this vector model. So it has two dimensions, valence being like, it's a good or bad, and arousal being how engaged or active you are. That's not like sexual arousal, but just how into it you are, how heightened your awareness is. And so when one experiences some emotion or affect of high arousal, it's often very positive or very negative. Think like fear or jubilation and joy. But when there's very low arousal and you're really bored and not active, it's just very neutral feeling. So we're looking to move people toward a productive state. And the key takeaway from this is that arousal can be measured in many different ways where valence is harder to quantify. So we're hoping through our device, through this project, to know something about people's level of arousal in their affect and help regulate it. The goal, as I mentioned, is to move to a productive mood state. And again, important to define, productivity here is not like productivity in the capitalist way of like making as most goods as possible. It's how you feel. Are you calm, cool, and collected? Are you engaged in a scenario? Do you like challenge? Are you, in your zone, so to speak? And it's directly opposed by things like anxiety, distraction, and stress. So this is what we're moving towards. And I'll spend about the next 8 minutes throwing more theory at you that I've really tried to cut down. So buckle up, but it's all very important to help understand the context of the project. And this is a little image that I think represents mind wandering, the little brain balloon. You decide if you think the same. So this project is situated in the field of embodied interaction. It's Gijs's expertise. And this is interaction, the study of design interactions. And embodied in this context basically just means that it exists in the physical world. We touch it, we feel it, we see it, and we perceive it through our bodies. At one point in time, people believed that the brain and the body were fully separate things. Like one was like the soul and the mind and the other was the body. But this takes a more unity view of it. Everything you perceive in your mind is through your body, through your experience in the world. So this is just to say, this is the general field we're in. And the products that come out of embodied interaction design are often haptic things, wearable devices, these things that we interface with. And the key takeaway here is that because we take this view of embodied interaction and the nuance there, we can try and make these cool, seamless, implicit designs, where if we had a separate view, that would be much harder. The one key theory within embodied interaction, going one level deeper, is called the affective loop. So it's an idea that through interaction, you can modify your affect, which is the goal of this project. And it's basically a basis for design. So what happens is you make a loop. Say I experience some emotional event. Oh, that's actually small. I experience some emotional event and I express it physically through the way I interact with the product. Either I'm like squeezing it really hard or however I interact with it. That product can then sense that in some way, process it, and generate a feedback response that I perceive. Then it modifies my mood state, my affect, and I can re-engage and create this loop of constant affective modification through engaging with a product. Vague, I know. Here's an example. You may have heard of this. It's called the Seal. It's a soft robot that they often give to people in like old age care homes because you can touch it, stroke it, interact with it a bit like a pet, but none of the difficulties and challenges of owning a pet. And through this, people can express themselves and their emotions in interacting with the product. So this is a good example of the affective loop. And a key thing I want to mention is it's very hard to interpret emotion through a design. I can't like squeeze a device and it's like, you're 72% angry and 3% sad. Like emotion and affect doesn't really work like that. It's more about making someone turn inward, engaging in their own dialogue, understanding their affect themselves. So that's what we're going for. And then implicit was the big word that I mentioned earlier. What is the difference between an implicit and explicit interaction? It's all about intention. Do I intend to generate some effect? If I don't, it's implicit. If I do, it's explicit. And the example of this is, say I am new to a town and I really like basketball or some indoor sport, and I want to go play. So I go to this new sports hall and it's, well, if it loads, it's dark, like I can't see anything. So I walk in there, whatever, I'm just trying to find my way. And all of a sudden, the lights turn on. I, through my walking, activated some motion sensitive light, right? So technically, this system perceived that I was doing something, accepted it as an input, and responded by turning on the lights. That was never my intent. I had no idea that it existed. That's an implicit interaction. In summary, I did something, it was observed by a device or system, and then it responded. And it wasn't necessarily my intent. Explicit is a lot easier to understand. It's a light switch. Do I want to turn on the lights? That's that. We are focusing on implicit interactions in this project because fidgeting is this thing that happens beside what you're actually focusing on, beside your other activities. we need to interact with it in an implicit way where we're not super focused on it. And then the last set of technical stuff to define are 3 terms that all have mind in them because I wanted to confuse you. So we have mind wandering, mindfulness, and mindlessness. Mind wandering is, as you may know, like when your thoughts drift off, your head's in the clouds, you lose your train of thought. Those are terms to define mind wandering. Mindfulness is also very popular right now, mindfulness meditation, a focus on the present and an awareness of yourself, your emotional state, these things. And mindlessness, or if something is mindless, is how we describe an activity that is simple, repetitious, performed automatically. You don't have to really cognitively process it as you're going. So as you might guess, I would consider fidgeting a mindless activity, and mind wandering and mindfulness to be semi-opposite each other. They're somewhat exclusive. It's hard to mind wander and be mindful at the same time. You would redefine meditation if you did. So mind wandering is another focus of this project, and I need to address it briefly. It's very much like in vogue in research right now. There's hundreds of papers written about it, and everyone's trying to figure out, why do we mind wander? What exactly happens? And what's the use of it? So right now, we think it's beneficial for things that are more creative, like creative ideation, things that are internal, understanding yourself, reflecting on yourself and others around you, and some abstract thinking. But we know for certain that it's really bad for reduction in, for memory, recall, and reading comprehension. If you are mind wandering while trying to read something and pay attention, you're going to lose it. And it's also often correlated with a low mood. It's not causing low moods like low valence, but it's correlated with it. So that's interesting to note. So the big takeaway here is that in the context of what we're aiming for, this productive mood, mind wandering is a harmful thing. So we're aiming to reduce it. This is not a universal statement on the benefit of mind wandering, but a statement in this context. And then the very last bit about mind wandering is this idea that it can be extended. So this is when you use an object in the world to help you in your mind wandering. So this video will probably be recognizable to you. You have your phone on the counter while you're working, you get a notification, you go pick it up, you open Instagram, and then about 20 minutes later, you're like, oh, what am I doing? This was not what I was supposed to be focused on. You in some way were mind wandering, even if you were looking at some content on the screen, and it was through this object. In this instance, your phone. And so a lot of research, or some research, has been done on phones, these very technologically enabled objects that have infinite potential in what you do with them. That's the whole point of a smartphone. So my first outcome of this project, and my first thing I created, is a theory about how fidgeting can be used in the same extended way, but reduce mind wandering. So I called it reflexive focus bounding, and it's basically putting your brain in a box and preventing it from mind wandering too far, as when you use like a fidget object. So the idea is that a fidget object limits the distance or severity of your mind wandering. If you're using something with infinite potential, infinite like ways to use it, you can chase all those paths. But if you're holding and using something that is simple, repetitious, and a really known quantity, if your mind wanders towards it, it's much easier to recenter yourself on like concentrated, focused thought. And as I mentioned, the key is the repetitive automatic thing. So I've made this little like video next to like abstractly help you understand this. I hope it works, but it shows your mind wandering in sort of like a sine wave and the effect of a fidget object to help bring you back. So the train tracks of thought are linear, but we're not on there. We're just going back and forth, mind wandering. And if you start using a fidget object to bound it, these walls close in and help limit the severity of your mind wandering. And then eventually, even if you're not always 100% focused, you can stay more focused. So this is the first project outcome, this proposal of reflexive focus bounding. Sorry, Andrew. And it's important to note this is a theory. It's validated by a lot of what we saw, but theories are theories and need more validation. So as I said, this is the first building block towards our end project result. Next, we did some more research, as one does. This is a very research-focused project. And I'll skip quickly over the first two because the last one, the landscape of fidgeting, the second project outcome, I think is really important. So at first we did an introspective study. And when I say we, that was myself, Han and Heist, we all looked at our own fidgeting behaviors and said, why are we doing this? What is it doing for us? We did some lightweight experience sampling. And we found our key takeaway is that fidgeting is often unaware and without a known purpose. This was like 3 weeks into the project. So we really didn't know what we were dealing with. And Hyon provided this clip of his favorite fidget object, an Apple AirPods case, one of the ways in which he uses it. So just an example of what we started learning there. Then I looked at a survey that a fellow master's student, Miriam Ayala, I think her last name is, did about what caused stress and what we did to respond to it. And I wanted to see if fidgeting appeared in something that wasn't about fidgeting at all. I didn't even ask about it. The answer is no, it didn't. But people did talk a lot about physical activity. That was the #1 response to stress. They wanted to do physical activity, and it was often after they were stressed. And most regulation of mood and emotion suggests you should do stuff in the moment, like a reframing or some way to compensate for it. So we see an opportunity to bring small scale physical activity in the moment with fidgeting. That was our big takeaway here. And the last thing, this is the second big project outcome, is what I'm calling the landscape of fidgeting. And it was a reflexive thematic analysis. This is just like an analysis process in literature, a qualitative, very personal process. And so there was a data set that exists of over 170 submitted fidget objects. They were some of the ones on the second slide, and text descriptions of what they are and how they're used. And I went through this picture that you shouldn't be able to read is me going through and picking out details out of it and categorizing it and coding it, saying what this is really telling me. And with this, we create a map of all the themes and ways in which fidgeting is important and is used. And this is a lot and could be talked about for the rest of this time. So I'm going to highlight what I think is most important for this project. First, we saw fidgeting as inherent, ongoing, and extensive. Those are the 3 words I used. And I don't want to like claim too much, but it's almost in people's DNA. People talked a lot about how they didn't have a choice here. They can't remember when they didn't fidget with something or fiddle with something or whatever word they chose to describe their behavior. And the one participant over here even buys pens in bulk such that he can destroy them on his business trips. And he needs to buy them in advance because he needs to have them with him. And this is the type of embedded behavior we see with fidgeting. That's how important it is. This was really fascinating to me, which was how important the choice of what you fidget with is in your self-identity and in your expression of self in a public setting. So people were afraid they would look like a nonsensical, senile Greek uncle if they used these Greek necklace worry beads. And then people have also held on to stuff since the 90s, since 20 years before this data set was collected. And in some way that becomes part of them and has a really close, tight meaning to them. So we need to be careful of that or cognizant of that as we move forward. And then lastly, I was very glad to see this. Most people this was the most common thing I found, was that people wanted to fidget for attention and for focus, which are parts of productivity. And people have this idea that if your hands are occupied, your mind can stay occupied. It's this like duality. It's important to say that maybe this isn't always scientifically proven. There's lots of debate on either side, but how people perceive it and feel it and experience it is this important attention assisting way. And I like the one on the right about the AirPods, both because it's AirPods and because it, I think, validates that focus bounding theory I mentioned. This participant lost their favorite, their ideal fidget object, and then they became more distracted fidgeting with other things, including, they mentioned, their phone. So it suggests that people can find an optimal way to fidget for them. So this is the second building block, this landscape of fidgeting. And the next thing are worth mentioning are some key assumptions and requirements. One key assumption, to be specific, is that people will express an affective state through the way they interact with something. And we see this in the data set, in the descriptions people give, but it's not proven yet through any published literature. There was one with children, I should say, that proved this, that kids would squeeze things really hard when they're angry, and these sorts of very obvious connections. But we need to count this as an assumption and be careful that it's not something we know. And then on to requirements. So I needed to translate everything that I had from these first 2 building blocks, as I'm calling them, into requirements for a design, which is not so easy. And people on the call, I think, are from my bachelor program. We did very, strict program of requirements where it had tons of lists of key features to meet with, like a best case and a least acceptable case. But since this is a very research focused, research through design type project, I had very non-specific requirements, such as we need to be able to sense a user's input to the device and respond to that. We need to mirror that natural implicit state of fidgeting use. We need to provide some sort of tactile pleasure, because most people referenced how they just really liked touching things, cold surfaces or hard surfaces. And we need to make it socially and personally desirable, as I mentioned with the second theme about one's identity. And ideally, for my own sake, to function as an exemplar of this focus bounding, because everyone wants to be right about the thing they're proposing. So I will share the concept and then the prototype, which is a bit backwards, but I think it makes sense. So the envisioned concept I'm calling the Fidget Spheres. They are 2 spheres with a ring around them. And I'll explain where they're used and then more about them. So once it loads, this next scene might look familiar to you. You may have been here before in a classic lecture hall full of people with computers. And if you've been there, you can probably feel it inside, just like the idea of everyone around you typing away notes. There's a lot of like social faux pas you can do, dropping your metal water bottle and all these things and making a bunch of noise. So there's a lot of expectations of that environment. And if perhaps you're a bit removed from school, these might be more your environment, this impossibly curated stock photo of a Zoom environment, or a more real photo of the studio lab upstairs. These too have social expectations of how you interact in the environment and fidget. But for this project, we're focusing on these people in a traditional sort of office environment, working maybe hybrid from home, maybe in the office, and also higher education settings. So back to the Fidget Spheres. You may know of bounding balls, or sometimes in America, we call them Chinese meditation balls. They're the ones that are colorful on here. It's 2 spheres that people predominantly in China use, and they rotate around each other in their hand with one hand. They're often made of metal or ceramic with like a little bell or ball inside. So they make noise if you fidget or if you use them too roughly. And the goal is to be as smooth and consistent as possible. There is some cultural association with like old people using them, so I hear, but I think in the West, we don't really know that. This is the general concept. And the goal, as I mentioned earlier, is to enter into this effective loop, this responsive sort of interaction. So we need to do a few things. We need to sense movement. That's like both the force and frequency of the movement. And a spinning ring is most people's, spinning a ring, I should say, like a physical ring on their finger or something in space, is the most common fidgeting I found in the data set. So we wanted to include that. But we also wanted to make this very flexible. You can interact with it in any way. And that's part of why the concept is so simple, just spheres, because it really opens up the possibility of how and what you can do with it. And again, give that responsive feedback. So this video shows how the balls measure movement. It's both linearly in 3D space or rotationally in 3D space, or measuring the speed and thereby like the force applied to that spinning central ring. And as I mentioned, I want this to be responsive. So it's going to give feedback. How is it going to give feedback? We're using both vibration feedback and what I'm calling force feedback on that central spinning ring. So as one spins the ring harder and harder, and expressing some sort of like elevated affective state, you can it can provide, as the graph shows, well, it lagged, but it can provide some feedback proportional to the amount of force or speed you're applying to the fidget sphere. I'll try and run that again, but I think my computer is having a really good time with this. Yeah. So as the ring speed, well, it gives up, that's fine, you get the point. It's responsive feedback based on how you're interacting with the object and how you're expressing your affect. And then we see, looking to the future, the potential to integrate this even more like in your life, perhaps have it record data from what stressed you out in the past or what's made you engage with it most in the past, and predict that in the future, looking at your calendar and say, this meeting with this person is probably gonna make you wanna fidget. So let's tell you in advance so you're ready for it. So that's one way we can use these. So just to break down what it is, both in an idealized form and a prototype form, it's a sphere, as I mentioned, with a DC motor for feedback, a 6-axis IMU, so that's gyroscope and accelerometer, with an aluminum casing around it all, and inside we have a motor, vibration motor, motor driver, battery, and then a bunch of bits to make sure it all nests together properly. And that's the envisioned concept. And now I'm going to talk about the prototype, which, as you can see, does not look like the envisioned concept. Because such is design. We start small, we build up, and we learn things as we go, leading to this envisioned concept. It's important to know the conclusions from this prototype did inform that concept. So I'll go through there. Oh, also, I didn't know where to put this. We made a looks like prototype and an idealized vision of what it looks like that does not function. It's just static. And I have it in a bag somewhere we can pull out. Oh, it's up here. When I'm done, you're all welcome to play with it because I actually think it's quite satisfying. But I made it here in the PMB on the lathe just to get the vision of what it looks like or could look like. As for the prototype itself, I really don't want to spend a whole lot of time on this because even I get bored with it a bit, but it has this sort of system architecture with a vibration feedback. And we also included squeezing force sensitive resistors in the prototype. One thing I will mention is the two types of actuators. There's many ways to give haptic feedback. It doesn't have to be vibration. It can be temperature and other things, but we stuck to vibration and we used both of the two most common vibration motors, ERM, so rotating mass, and a resonant actuator. So if you have like a Nintendo Switch or the newer PlayStation, they have the LRA type in them, this more modern actuator when you get the rumble from playing a game or shooting something. So that's the sort of vibration motors that are in this project. So this is what the prototype actually looked like. Again here, and I'll pull it out of a box, but you can tell this is not the same as the nice crisp rendered visuals. But again, we're just building it to learn. So on the top, the left-hand ball, the one with the green thing sticking out of it, senses force, and then the feedback is delivered through the right-hand ball. And the bottom pair, the left-hand one, senses movement, and the feedback is delivered through the right-hand one. So this was just to make it feasible to test and prototype. And the whole point of this was to test it in some way. So we did a evaluation session, which I think some people, maybe they're online, some people were here for that. They were just, oh no, Victor was there. So we did an evaluation session, a focus group of sorts to understand whether people could make a mental model of how they were interacting with these devices and the feedback given. Did it make sense? Was there a connection? And understand why people may or may not use these in context. And so what we found out is, ironically, the prototypes were almost too engaging. People were really hyper-focused on the interaction and the feedback regimes there too. And this might be because it was a focus group and focus is in the word, but it also could be the way the feedback is delivered. We also found that there was a delay in your action and the feedback response, and people didn't necessarily like that. And they definitely didn't like having to do two hands at once, separate, wired up. So a lot of this makes sense. And the goal was to take that all and do another user test, but it was only 100 days. So we ran out of time. But this information informed the final prototype that I've already, or the final vision concept that I've already showed you with the fun renders. So I'd like to finish, because I have like 3 minutes, with some future steps, what I think would be valuable if someone else were to keep this going on. And I put this as the future image because everyone knows that like colors are futuristic. So I figured this was what we should do. So there's a project that exists called the Smart Knob, or the Haptic Knob, and it's very, very new. It's an open source project about like, you know, like those smart thermostats on the wall, like that kind of knob. Imagine that, but with infinite different types of feedback that are programmable, different types of notches or forces, whatever. So we want to take that because it's open source and just shove it in the Fidget Sphere, basically. But that takes some adaptation and work. So that would be the next step. And from the user test, we see we need to unify both the sensing and the response in one ball, test a bigger variety of vibration, and do it in context. Give it to someone for a day or a week so they can see what it's like in context. And that will better inform how to bridge this like mental model and make sure the feedback matches how they interact with it. There are also a few general opportunities to prove whether this focus bounding theory is true or not. Maybe doing an experiment that tracks how long it takes people to return to a focused state, if possible. We need to validate our assumption that you can express affect through tangible interaction. And a personal favorite of mine, I really like this idea of mindlessness. So it'd be really cool to develop some sort of criteria or framework to design for mindfulness, applied more broadly, or mindlessness rather. See, mixing up the terms. But I think there's a lot of value in that because a lot of what we do in everyday life is mindless. So to design for that would be of value. So to wrap it all back together, there are 3 building blocks in the project: the theory of focus bounding, our landscape of fidgeting, and what I'm saying is prototype development. And all of these fed together to create the Fidget Spheres, which are, to my knowledge, the first kind of example of an affect regulating fidget object, especially one that uses this implicit unaware type interaction or intends to use that. So with that, I thank you for your attention. And I am open for any questions you have. So. did it.
Right. Any questions from audience?
Without anything.
Yeah, sure.
Yeah, I guess kind of a more general question. How did this idea for this project sort of come into your mind? Where did all of this come from? Because it feels really personal.
It is very personal. It's a good question. The question is, where did the project come from? So I was in Han's introspective design class, and he assigned us a reading about something to do with introspective design. And I went home for Christmas not having a project, not having a graduation. And there was one line in it that talked about designing fidgeting, and it had one reference. And I was like, that's it, that's the project, because I love fidgeting. I do that all the time. And that reference turns out to be the one that published this data set. So that was the only papers on this topic directly that existed. But through that, branched off, and that's how the project started. But yes, it was a personal, self-generated sort of thing.
Really nice. Can I ask a follow-up?
Yeah.
So it sounds like the kind of literature landscape in this area, the specific area you were looking at, is really quite sparse.
As it relates to fidgeting for any sort of emotion or affect, yes. There's some other stuff loosely about like whether children pay attention in school, like to a blackboard and math and stuff, but otherwise it's pretty empty.
Okay, yeah, because I was wondering how this theory that you've developed, how does this compare to other theories? Are there other theories in this space that relate to your work?
It was late in the project, so I haven't done maybe the fullest of lookings, but I didn't see much that related to it. This extended mind wandering like through a phone was proposed by one author last year, and they believe that through a phone is very, very bad. And it's like the reason why everyone is just bad now in general, because we're all mind wandering through our phones all the time.
Yeah.
It's a bit of hyperbole, but like that's about the closest thing that there is to my knowledge. Thanks for the question. Anybody else? June.
So a lot of these fidget toys are made out of cheap material that you can buy and lose and quite easily toss aside. But this is a lot more, I'm expecting to be more expensive.
Yeah, it would be.
Would that be like a barrier point to?
Yeah, it's a good question. So the question is, this is very expensive and probably, complex, but everything on this table that I brought is very cheap and simple. Is that a barrier to adaptation or adoption? I would say probably in some ways for a certain group, maybe college students especially. But what I saw through that data set is how important these objects become to people and how they don't lose them. Back to your point about like why I came with this project, I've carried some buttons out of a PlayStation Portable with me since like 9th grade. They're here in Delft because I fidget with them, and that's important to me. So I think there is this intense buy-in, and people would be willing to spend a fair amount of money if something was going to be that important to them. But it's an assumption I'm making, and the vast majority of products are 6 cents a piece, you know. So I feel it fits how fidgeting is actually used, but the market says otherwise at this moment. Nanda and then Parsi.
Can we also fidget with something else in our hands and design for that? Is that
Yeah,
useful?
that's a really good question. For this project, and I left it out of the presentation, I define fidgeting as micro, so like small scale object mediated with your hands. But a lot of people say that like leg bouncing when you sit behind a desk, like while you're like, is also fidgeting. So I would say, yes, you can totally fidget with any part of your body. And you can also, fidget with your hair and all these sorts of things. But for this context, I chose with the hands, but it's definitely can be much broader than that. Was that the answer to your question?
Yeah, because like your hands are like very reflective. Yeah, there's a lot of receptors in your hands for like grabbing and stuff. But I was wondering if you could like accomplish the same results while typing, for example. If you did something with your feet or whatever.
That's a really good question. And back to the question about is there literature in the space? That's the direction that existing people had started to go in, was something that you could be fully with your hands on the keyboard typing, but still helped you fidget in some way. They didn't come up with much. I also didn't chase that down, but I think there's potentially more opportunity in that than when you're holding in your hands. Because we sit at our computers typing all day, and it's hard to do that if your hands are busy. So yeah, good question. I chose another way. Parasu.
Yeah. First of all, thank you for the presentation.
Yeah.
It was really inspiring, and it feels like that what you're working on is very new. I think. But my question was that you mentioned somewhere that you applied research to design.
Yeah, I started to do it.
Yeah, and now I'm wondering, how did you apply that in such a research-based project?
Yeah, my intent was to produce more generations of the prototype and use that to influence the research and use it as the outcome of the research, the
Yeah.
artifact. I don't know if I necessarily got there due to the making only one prototype generation, but when we started, that was the intent. And I'm really not certain how else to categorize this process. You know, we have in design, we have the double diamond model or a million other models that I'm forgetting at this moment, and none of them really fit. So I just called it that, but I also am not certain that it fits exactly. So fair question for sure.
Thank you.
Anybody else? Yes.
It's very interesting, or I'm quite interested in the material class, like it looks, the materials
Yeah.
are clearly chosen for different type of fidgeting.
Yeah.
And what is your thought behind why the ring is rough and the sphere is smooth?
Yeah, part of it's aesthetic and part of it's for grip because people want to turn things and have grip on it. So the knurling pattern is a grip mechanism. As it relates to the actual material like aluminum, wood, or all that, it's a lot. I wanted to make different ways it could appear aesthetically just to see the variety. And the research I found on what people perceive about materials is not in the fidgeting context, but generally goes with what you would expect. Like people like hard, cool things when they need to calm down a bit. And they like softer, warmer things when they need like comfort in a more like human or warm way. So I chose generally harder materials in this more like calming state. But I think potentially you could have swappable materials and then match your own preferences for what you really need. But that's about the depth I went with the material choice. Thanks.
I just thought of another one.
Yeah.
When you were talking about the affective nature of productivity in that sense,
Yeah.
you were saying you're not defining it in the kind of capitalist kind of hustle
Yeah.
culture sense of productivity.
Correct.
So firstly, how do you define it then? What kinds of emotions and emotional states are associated with it? And on the graph you showed us previously about arousal and valence,
Yeah.
where does it sit there?
Yeah, that's a really good question. I know that productivity, the one I'm aiming for is a positively valenced productivity. And I'll start with the first question, like how does it differ? What I meant with that statement is like, we define productivity, at least in like industrial engineering, as the throughput, like how many objects can you produce? And I see productivity as something, it doesn't have to produce a valuable good you can sell, but it's just you working at something you enjoy, like moving through it quickly. Like I like doing crosswords a lot now, and like doesn't generate value in any way, but for me it does, and I'm productive when doing it. And that's the sort of productivity I'm seeking to engage. So that's a positively valenced, medium to high, like arousal state with that engagement, almost tunnel visioning into something you hope for.
So how does it differ from focus?
I think focus is an element of productivity for
Right,
sure.
okay. So it's like a characteristic of that state.
Yes, that's what I would say.
Nice.
Yeah, thank you. Good question as well. Anybody else? Let's plumb out of questions.
The same sets all the questions.
Aha!
I can ask
Yes,
another
got
question,
one.
yeah, for sure. Well, Jack, thanks for the presentation.
Thank
It was
you.
very clear. So I'm wondering, you now made this envisioned prototype. Do you also have maybe did you think about well, possible brands, companies to bring out this kind of well, product? And are you also thinking about approaching any brands?
That would be
with
fun.
it?
I did not think of any right yet. I think what I saw when I ordered these products is we're really in like the AliExpress era of fidgeting, where you could buy the same thing from 20 different manufacturers for about the same price. So I don't know of anyone that specifically operates like in the space of fidgeting. There's a couple of niche, like fidget.com has stuff or whatever, but no brands that I've thought of off the top of my head. Maybe opportunity to make a startup, you know, that sort of thing. But I think producing this as it exists with the certain hardware that I have in it would be complex and cost prohibitive. You'd need to go more custom about it. So I didn't really think past, you know, the prototyping stage on that. But if there's a market for it, might as well build it.
I think perhaps like a brand like Philips or like
Yeah.
in the medical space as well could like market it as something to reduce stress or.
Yeah. I should say the
Yeah.
only project that I've seen that relates to this, even in a spherical way, is a speculative design project from Philips in 2008. So I think they were already thinking this, and then it was produced and died basically, like the paper about it. So perhaps time is now, you know, but they were at least thinking along this direction back then.
Thank you.
Yeah.
All right, then that's the
Great.
next question.
Thanks.
So I will ask Jack to have a relaxing 15 minutes
Sounds good.
with the audience, and I'll go back to my office
Yeah.
to talk to Heis.
Yeah.
Okay. Then please join us in 15 minutes.
Yeah, we'll do
You
so.
know where to find me.
Yes, I do.
Okay,
Thank you.
then we'll come back.
Yay. I'll pull out the looks like prototype and feel free to mess with other stuff. And we brought some food and stuff. So